Okay, angle similarity theorem notes. Earlier in the year, we talked about triangles or polygons that are congruent. And when we talked about that, we had a triangle, and it's not going to be perfect. I'm trying, but I am not going to get it perfect here. That if they were congruent, this side is equal to this side is equal to this side, or I should say the sides are congruent to each other. This angle is congruent to this angle is congruent to this angle, and then this would be congruent to this. Now, we've talked about that briefly earlier this year, but now we're going to talk about triangles being similar. And triangles are similar if they have congruent corresponding angles and proportional corresponding sides. So they don't have to be equal sides, they're just proportional sides. This is called the angle similarity theorem, and it states that if two angles of one triangle are congruent to the corresponding angles of the other triangle, then the triangles are similar. Okay, this symbol right here means similar to. So it says, identify the triangles that are similar by AA similarity theorem. So this first one says that this line right here and this line right here, or line segments, are parallel. So if we remember from our lessons on parallel lines, if I have parallel lines and they're cut by a transversal, and if you need to make these longer so that you can see it, this angle right here corresponds to this angle right here. So that means that they are congruent to each other. Then, if I elongate this side and this, those are parallel, and that's a different transversal. This angle right here is congruent to that angle right there by corresponding angles. So because that two angles of a triangle, so we're talking about this angle right here and this angle right here, so that's angle DCJ is congruent to angle HGJ, and angle CDJ is congruent to angle GHJ. That means that these two triangles are similar to each other. So we have to go in the same order. So we started at J, then C, then D. So J, I did not mean to do it in that. My highlighter is what I meant to do. J is in both of the triangles. So that means that J is going to go first. Then it went to C. So if we look at C, C's up. Oops, I wanted to do that a different color. C is up here, so it corresponds to the letter G. So then we have G, and then we have D, and that corresponds to H. So triangle JCD is similar to triangle JGH. So now we're going to look over at this one. So if I look at this angle, look at this. This has a right angle and this has a right angle. Then, are there any other angles that are congruent to each other? Well, guys, isn't this angle right here and this angle right here, those are vertical angles. So So that means that we have two angles of a triangle that are congruent to two angles of another triangle. That means the two triangles are similar. So we are going to do, that means these go together. So Y is in red. So in the other triangle, that would be W. Then it says V. Well, V is what color is that? Green. So that means we do V for the other one. And then we have Z, which is purple. So that gets us X. So WVX. So let's look over here at this one. So it tells us that this angle right here is the same degree as this angle right here. So that means that those two lines are parallel. But that's okay if we don't know that. This angle right here is in both of the triangles. So two angles in a triangle are congruent to two angles in another triangle. That means that the two triangles are similar. So if it's easier for you to have the coloring like I'm doing, that's a great idea. So T is in both of the triangles. M is purple. What else is purple? N is purple. Then you have R that's red and S that's red. I think that's supposed to be an S. It almost looks like a 5. Okay. So then it says, are the following triangles similar? Well, we have to figure out what this angle is right here. So the measure of angle G plus 102 plus 30 should equal 180. So the measure of angle G plus 132 equals 180. Subtract the 132. That gets me the measure of angle G equals, that's an 8, that's a 48 degrees. So this is 48 degrees. And if I look at this, angle E is 102, angle L is 102. Angle G is 48, angle N is 48. So two angles in a triangle are congruent to two angles in another triangle, then they are congruent to each other. Or sorry, the two triangles are similar. So angle E is congruent to angle L, and angle G is congruent to angle N. So triangle EGF is similar to triangle LNM. Okay, over here. This angle is congruent to this angle. This is a vertical angle, and this is a vertical angle. So we have two angles. So we have angle X is congruent to angle H, and angle XYZ is congruent to angle HYJ. So triangle XYZ is similar to triangle HYJ. The triangle has measures 42 and 63. Another has angle measures 63 and 70. So if we look at this, we have X plus 42 plus 63. That equals 180. So X plus 105 equals 180. Subtract 105 from both sides. So x equals 75 degrees. Over here, I have x plus 63 plus 70 equals 180. X plus 133 equals 180. Should have probably done y. That's okay. So x equals 47 degrees. Now, do they have two angles that are congruent to each other? Well, they have the 70. No, they do not. They have the 63 that is congruent. But they don't have another one. So no, they are not similar because there are only one set. Oops, that's a weird looking F of congruent angles, not two. Okay, so then we're going to come down here. Going to do a little review. So if angle 3 is 48 degrees, what's the measure of all the other angles? Okay, so the measure of angle 4 plus 48 degrees equals 180 because, oops, sorry about that. These two are a linear pair. So I subtract 48. I get the measure of angle 4 equals, that's a 2, that's a 3, that's 132. So this is 132. Well, angle 1 and angle 3 are vertical angles, so they are congruent to each other. Angle 2 and angle 4 are vertical angles, so they are equal to each other. Angle 2 and angle 6 are corresponding angles, so they are equal to each other. Angle 3 and angle 5 are alternate interior angles, so they are equal to each other. Angle 2 and angle 8 are alternate interior angles, so they are equal to each other. Angle 1 and angle 7 are alternate exterior angles, so they are equal to each other. Which angle or angles are congruent to angle 1? So angle 1 is right here. We want to know the congruent. So angle 1 is congruent to angle 3 because of vertical angles. Angle 1 is congruent to angle 5 because they're corresponding angles. And angle 1 is congruent to angle 7 because they are alternate exterior angles. So now angle 2 and angle 8. So now I don't have this. We're doing something different. Angle 2 and angle 8. So if I look at 2 and I look at 8, those are alternate interior angles. So that means they're equal to each other. So I'm going to set these two equal to each other. 120 equals 16x plus 8. Subtract 8 from both sides and get 102 equals 16x. Divide by 16. I'm going to guess that that's 7. Let's actually put it into the calculator. and see if I'm right. Oh no. Angle 2 and angle 8, they should be... Oh, that's because this is 112. That's why. So x is equal to 7. Okay, so down here, it wants to list all the alternate interior angles. So if I look at alternate interior, interior means they're between the two lines. So that's 2, 5, 3, and 8. The alternate ones will be on opposite sides of the transversal. So 2 and 8 and 3 and 5. So angle 2 and angle 8, angle 3, and, oh, no, angle 5, Kimberly. Okay, alternate exterior angles. Okay, exterior means that they're on the outside. So they're on this side, they're on the outside, and they're on alternate sides. So 4 and 6 and 1 and 7. Corresponding angles means they sit in the same spot. So top left. So angle 1 and angle 5. Then I have top right. So angle 2 and angle 6. Then purple. Bottom left. So angle 4 and angle 8. And last but certainly not least, we have angle 3 and angle 7. Then it says same side interior angles. So they are on the interior and they're on the same side of the transversal. So these two and these two. Angle 2 and angle 5, angle 3, and angle 8. Then it's same side exterior angles. So on the outside, so those two go together, 4 and 7. And then 1 and 6 go together. Oops, then I want vertical angles. Okay, so vertical angles go this way. 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 So 5 and 7. And then 6 and 8. Trying to keep it with the color. 1 and 3. 1 and 3. And 2 and 4. And then it wants the linear pairs. So, my linear pairs. So, linear pairs, linear pairs, linear pairs, linear pairs. Oh, that last one I should probably do red. Okay. 1 and 2. And then 3 and 4. And then 5 and 6. And then 7 and 8. Okay, so then we also have the other direction. We have 1 and 4, 2 and 3, what other color can we use? Oh, brown. 5 and 8. And 6 and 7. So 1 and 4. And then 2 and 3. And then we'll do black first, 6 and 7. And 5 and 8.